We have built a WebAssembly-based modular blockchain, and in our quest for the most flexible, modular, and scalable blockchain, we have achieved a very important milestone: changing the consensus protocol by governance on a chain that is live and running. And this is what I will demonstrate today. Meta-consensus is a type of consensus about the consensus mechanism of a chain. Consensus about consensus. And our implementation on Mythos allows for live meta-consensus while the chain is running. Done by governance contract, it is revertible, and it is done by using consensusless contracts or meta-consensus contracts. This is a major innovation for blockchains and something that nobody else has. Along with our multi-virtual machine system that supports multiple smart contract languages, the ability to choose and change consensus protocols makes our Mythos chain the most advanced blockchain. And don't forget, Mythos is built by volunteers who are donating their time to build tools for self-determination. To understand the following demo, you need to know that the consensus protocol is implemented as a WebAssembly smart contract. I have started with implementing a RAFT-based protocol adapted for blockchains in AssemblyScript. And this is our first type of consensus, the default base flavor. I introduced this RAFT-based consensus in previous videos, and more, I showed you that we have built a finite state machine interpreter as a smart contract. So our consensus protocols are implemented as finite state machine diagrams. In fact, our devs can build any smart contract just by creating a finite state machine diagram. Next, these consensus contracts are executed by the same engine that executes any other smart contract, but the data is written in different types of storage, and we previously called these consensusless storage. Block and chain data are meta-consensus deterministic data. So this can be read by any other smart contract, so Mythos is the first chain with introspection. But there is also meta-consensus non-deterministic data, and this is data that is different for each node. The consensus contract is provided as a precompiled contract. And for this demo, I will deploy another consensus contract on the chain with a slightly different heartbeat value, so we can check that something has changed. Then I will make a governance proposal to assign this contract the consensus role, and then we will watch the consensus change process. This is our Mythos testnet 22, Rouen 2024 version. We have a leader node here that proposes blocks and a follower node here that validates the blocks and then commits them after the leader determines that the majority of the nodes have received the block. And notice the logs. We are finalizing blocks here, but we also have some logs mentioning a heartbeat timeout of 6,000 milliseconds, which is 6 seconds. And this is the leader heartbeat from the RAFT protocol. In the new consensus contract, this value will be 5,000 milliseconds or 5 seconds. And we also have an explorer here, so we can see the blocks and the transactions. And I also have a dApp here that allows us to deploy and interact with various types of smart contracts on Mythos, from Solidity and EVM contracts to JavaScript, Python, and other WebAssembly compiled smart contracts. But we have chosen now the finite state machine interpreter, and I already have here the state machine definition for our new consensus contract. along with this definition, we also give a library address with custom functions for this particular state machine. And this is one of the dependencies. The first dependency is the label of the smart contract that can interpret this diagram. And now we deploy this contract. And we should see here the block with one transaction. Let's open it. This is the store code message, and if we go to the actual transaction, we can see our dependencies and the bytecode, which is actually the configuration that we saw in JSON form. And here we will find the code ID, which is 25. So now we can instantiate this contract. And I have here the values that the state machine expects, and we will transform them to base 64. First, we'll put them here, and we should see the heartbeat timeout with a value of 5,000 milliseconds, and then we'll get the base 64 value. So now we will instantiate this contract with the code ID 25 and this instantiation data. Okay, we get a transaction hash that we can look at, and we see the message instantiate contract, the code ID, and we have our contract address. Now this is the contract address that will be used in the governance proposal. So let's write the governance proposal command here and copy this contract. And what this does is register this contract in the role named consensus under this label, consensus RAFT version 002. And let's send this. We have the transaction, but we can actually look at governance, and we see here a proposal. Now, let's vote on the proposal, and this proposal will have 20-minute voting time. So this is proposal number 2. We are voting here, and we should see the voting result here. Now the governance proposal, but let me start again so we can see the leader logs here. By the way, all of the interpreter contracts that interpret EVM or JavaScript or even our current state machine have the interpreter role, and these are also meta contracts. Now, after the 2 minutes pass, we should see the consensus change on both of these nodes. First, we'll see it in the leader, and then we'll see it in the follower node. And what happens is that the consensus contract is the one that proposes and finalizes blocks. And after it finalizes a block, it actually looks for any consensus changes in the events of that block. And Next, it will try to set up the new consensus contract, and it will call the setup function by sending the setup event on that contract. And the new contract has access to all the data that it needs to bootstrap itself. And if that somehow fails, then we will revert to the previous consensus, which is executed by the current consensus contract. If that works, then we will start the new contract, we will stop ourselves, and then continue with the process. So let's look again, because we should see the consensus change anytime now. And let's actually search for this log. Okay, so it has been done. So let's look at the logs here. We finalized block 4072, and it has found a new consensus contract at this address, and this is the address that we have given. And by the way, let's look at the governance proposal, and we see that it has passed. So the next consensus contract is started here, but if we look above, we actually see the process has started earlier. So after we have finalized block 4072, we have started migrating contract storage. So this happens because the storage of the new contract has changed from a normal contract to a consensusless contract. We have changed from core consensus to single consensus because it's actually non-deterministic data that this contract holds. It's the data for each individual node. So we migrate this contract storage, and then we are setting it up. So this means some data is migrated to the new contract, like node IPs, validator data, mempool data, and so on. So then we stopped the current consensus contract that was working. We finalized the block, the 4072 block, and then we had the command to start the new consensus contract. So now we know the next consensus contract is started, and this is still from the previous contract. These are some heartbeat commands that will start but then will end, and we know it's from the previous contract because it has a heartbeat of 6 seconds. And it ends this execution because it is from the old contract. So here we already see the new consensus protocol starting because it tries to find the next leader. It tries to find the leader. So it sends vote requests for this node to become a leader. And it actually became a leader because it started finalizing blocks again on the new consensus contract, which uses a heartbeat of 5 seconds. And this process was repeated on the follower node. We see the same thing. The next consensus contract was started. Any previous executions were ended. And here we see election timeouts. So again, this was the new consensus protocol that was started, but this node has voted for the candidate, and the candidate with ID 0, which is the leader node. And then it continued with receiving the new blocks from the leader, and it continues the chain. And we see on the Explorer that the chain is continuing to run on the new consensus. So you have witnessed a consensus protocol change on a live running chain by governance. In future videos, you will see more consensus protocols implemented as smart contracts and much more.